Secondary hazards then, ladies and gents. This follows on immediately from the previous video on primary hazards. We're filling in a table. You're just filling in the first two columns. You're not worrying about the third one. I'm going to talk about the third column at the end of today's video. Right, secondary hazards. They're indirect. They're one step removed from the volcanic eruption, and I will try to emphasise that as we go through. We are starting then with Lahars. You can call Lahars volcanic mud flows. Lahar is an Indonesian word because unfortunately they experience a lot of lahars in Indonesia. And it's a little bit like, well, if you experience lots of those, you kind of get naming rights, really. But if you called them volcanic mud flows, you're not going to be incorrect. So the primary hazard is the ash. So the secondary is if that ash combines with melted ice or rain or melted snow, that's when you potentially could get a lahar. Okay, so that's why it's secondary, because you need the ash, but you need something else to happen to it. You need it to mix with water from somewhere, and then it will flow downhill. So it's a form of mass movement. We talked about flows before in the coasts module, and flows, this is exactly what this is, but it has a very specific formation, which is the ash from the volcanic eruption. Now, you know a little bit about Nevado del Ruiz from case study nuggets at the very beginning of the module, and unfortunately Nevado del Ruiz is very much the best or worst, depending on how you want to think of it, case study for Lahars. 23,000 people died, complete tragedy, absolute disaster. So here is the volcano. Here was Armero, and I'm using past tense correctly there because the Lahars destroyed it completely. Now think about gravity and think about the word flow. Generally speaking, they are going to follow river valleys because river valleys are going to be the low bits, aren't they? Therefore, ladies and gents, predicting the direction of Lahars is relatively straightforward, and therefore we are now theoretically much better at not putting towns or big towns in the way of potential Lahars. But unfortunately it took Nevado del Ruiz happening for us to sort of realise that. Now, this YouTube video, really interesting. It's very dated, it's very old-fashioned. There are images of dead bodies in it, not gratuitous at all, just factually. It's a really interesting video just to get across the scale of the devastation and just how awful it was. This is just a website of possibly particular interest to those of you doing photography or art. It's about one of the most famous photographs ever taken, and it's of a girl called Amira Sanchez, who was part of this Nevado del Ruiz disaster, and that website just gives you a bit more information. It's a tragedy whichever way you look at it, and I can't box it up any differently, but it's important for us to know because it was the turning point in volcanologists making sure we just never allowed anything like it to happen again. Landslides. Okay, so we know about landslides from coasts. Landslides are a type of mass movement where everything gets sort of jumbled up at the bottom, aren't they? Well, landslides can be caused by volcanic eruptions, okay? So the eruption shakes the ground, as it were, and then it can trigger a landslide. Now, here's the terrifying thing about them, and this is bonkers. I've said to you that landslides are a type of mass movement, and the definition of mass movement is the downhill movement of material under the influence of gravity. Volcanic landslides have so much power they can go uphill, which is just bonkers and scary and terrifying. So your case study for this is Mount St Helens, which is a very famous eruption, and you can see some stats that I've put there, and you can pause if you wish. That video, I'm almost certain you will have seen at some point in your education. It's very short, it's about 18 seconds, and it's just slow-mo footage of Mount St Helens erupting, and it will give you a sense of why volcanic landslides have so much power. And that is what the landslide did to the surrounding forest. So these trees are still stood up. These trees just look like matchsticks, don't they? They just completely got flattened by this incredible landslide that happened. Crazy, crazy stuff. I know, weird. I haven't spent very long on landslides because they're not the most important thing. So don't feel that you need to write much. Tsunami, right. Tsunami is a Japanese word because Japan gets lots of tsunamis, and so they get naming rights. You might have noticed a theme from Lahars, but there's not really an alternative. You need to know the name tsunami because that's what everyone calls them. If you have a volcano in or near the sea, they absolutely, definitely are capable of triggering tsunamis, okay? A lot of people think that tsunamis are only linked with earthquakes, and that is simply not true. Volcanoes very definitely are, but there has to be water nearby for it to be possible. And you can see what happens. So you get the explosion, which triggers a landslide, and then the landslide displaces the water, and hey presto, you have a tsunami. So there is some footage. I actually can't remember what that one's about. So that'll be a magical mystery tour, that one. Sorry. But some people quite like that little diagram. You could do a very teeny tiny version maybe in your description box. Now your case study is Stromboli once again. Stromboli was also your case study for lava bombs. I'm trying to keep the same volcanoes wherever I possibly can. Stromboli, they are quite used to living with a dangerous volcano because it erupts most days and it does occasionally kill people. But the tsunamis don't usually because they have this amazingly simple warning system. So if you hear a siren, you have to run uphill, which is fairly logical, isn't it? Tsunamis are going to come from the sea. Stromboli is a volcanic island. Oh, sorry, I'm trying to go back. So if you can imagine this as an island, if you run uphill, your risk of being affected by the tsunami is much reduced. But I can imagine, I've been to Stromboli, but I'm glad to say I wasn't there during a tsunami. I can just imagine that every bone in your body would be telling you not to run towards an erupting volcano, that it must go against, or yeah, your gut feeling quite badly. But the point here is that if you know your volcano, you know how it behaves, you can have systems in place to minimise deaths, which is great. Just a reminder, we have had much worse tsunamis. So Krakatoa, which is a caldera eruption, one of the most explosive, the loudest sound ever recorded, remember, on planet Earth. The tsunami waves created by that, they estimate at being at least 30 metres tall. And wiped out thousands of people. So there's just a reminder of that. Now, here's a nice little exciting thing for you. There is a possibility that one of the Canary Island volcanoes would be capable of triggering what they call a mega tsunami, something similar to what Krakatoa created. And you can see, so feet I know are quite old-fashioned, but essentially if you divide by 3, you will roughly get what it is in metres. So you can do a little bit of maths, ladies and gents, that'll do you some good. Anyway, scary stuff. I mean, really scary stuff. We would get a few hours, but, you know, there's going to be limited amounts of stuff, particularly if you lived on the east coast of America or the coast of northwest Africa. There's not going to be a huge amount that you're going to be capable of doing. Now, the hyperlink here, I have to apologise, it's not on iPlayer at the moment, but I leave it there because it's such a good documentary. You might be able to trawl the internet and find it, but it's a documentary all about the potential for the Canary Islands to create these mega tsunamis if and when their volcanoes erupt. So if you can find anything on YouTube or Netflix or Amazon, whatever, then yeah, definitely watch it because it is fascinating stuff. Right, Icelandic word, because it's an Icelandic thing. Are you noticing a theme here? Jökulhlaups. Okay, so these are floods. So if you have volcanoes erupting under ice, generally the ice melts. And then when the ice melts, you have a big flood. It's a fairly straightforward kind of process. And here you can see, so this is the ice beginning to melt as the volcano erupts underneath. And you can see now most of the ice has melted. This is amazing footage. This is a helicopter flying over a Jökulhlaup. And when these happen, briefly for about a day or two, they are the biggest rivers in the world. Like they have more water, I think, than the Amazon, but only for like 24, 36 hours or so. Because once all of that melted ice has gone out to sea, it's done. But on its journey, it does huge amounts of damage. This is a washed away road. This would be destroyed farmland. But the beauty of Iceland is, and yes, that's Icelandic writing, don't worry, I don't expect you to understand it. The beauty of Iceland is because they expect eruptions and they know that Jökulhlaups happen, they've got all the management in place, they recover really quickly, they evacuate people, they know what they're doing. And if you have learned to live with your volcanoes, then it is, possible to sort of live in harmony, as it were. It just requires good planning, good management. So they're Jökulhlaups. And that brings us finally to a much more familiar thing. You will have heard undoubtedly in the media that volcanoes produce carbon dioxide. Carbon dioxide is a greenhouse gas. Volcanoes are causing global warming. No. On a general year, volcanoes produce about 1% of the CO2 that humans do. Currently, they are definitely not responsible for warming us up. Maybe in the past, but we don't cover that in our syllabus. What we cover in our syllabus is that if you have a massive eruption with huge amounts of gas and ash, you will actually have a cooling effect. Okay, which you're probably sat there thinking, oh, that's great, because that could counteract climate change, and I see your logic, but you're also going to block sunlight for photosynthesis, which is going to affect all of the food chains on planet Earth, and then you start thinking maybe it's not such a good idea. Now, the one that I suggest you learn for exams is Pinatubo 91, because it's the most recent. Therefore, it's the most documented. I'm only going to talk to you about the others because it's quite interesting. So Laki is an Icelandic volcano, and it's now believed that Laki is partly responsible for the French Revolution. So the French Revolution was when the royalty were kind of killed and overthrown and put in prison by the ordinary people in France. And it was because the price of bread went up. It's the bit of history where Marie Antoinette famously said, let them eat cake, which is now disputed. It's that one. So if you spent half your money on food and then after a couple of years actually spending money on food took up nearly 90% of your earnings, you'd be cross, wouldn't you? I would be. I'm sure you would be too. And it led to this French Revolution. Well, it now turns out that because Laki produced this enormous amount of gas and ash, it probably is the reason that crops failed. And because the crops failed, there wasn't as much food around, and hey presto and hey presto. So maybe a famous historical event is the fault of an Icelandic volcano. Tambora, if you're into your art, this is a famous artist called Turner. And he's very famous for these spectacular sunsets. There's a hyperlink there for you to have a look if you're interested. These spectacular sunsets were all triggered by the eruption of Tambora in 1815. So he unwittingly was kind of recording, I suppose, the effects of that volcanic eruption in his art, which is kind of cool. Oh, sorry. Krakatoa we've talked about many times, so I won't go into that. Pinatubo, as you saw, that's all I need you to know. Okay, Pinatubo seems to have managed to cool the planet by about 0.5 degree. Doesn't sound a lot. Trust me, that's big. That is a big difference in climate. So yeah, Pinatubo is the one to learn. Right, the third column. Dun da da da. Hazard is something with the potential to cause harm. How bad that hazard is going to be depends on loads of different factors. Do not write these down yet. We'll talk about these in class when I'll get back into class. Let's not dwell on that. We'll talk about them at some point in the future. But let's just pick up on a couple. Aerial extent. So what you could put in the third column would be a note about, well, how big an area is affected. So lava flows are really only going to affect the area immediately around the volcano. Ash clouds could have an international effect. Tsunamis potentially would have international impacts. Jokulhaups are really only going to affect the country that the volcano is in, and so on and so forth. So you could think about how big an area is affected by this hazard. Is it quite local or could it be international? You could talk about how long they last. Pyroclastic flows, horrific, deadly, scary, horrible things, but they're going to be over and done with quite quickly, and then you could sort of get back to normal. Climate change, actually potential, a few months, maybe a year, could be potentially even longer than that. The Laki eruption seemed to have effect for like a good few years afterwards. So you could talk about that. You could put a note about the case study. So you could say, for example, and I'm not saying you would, but this is just an example, Nevado del Ruiz, the Lahars came down in the middle of the night. Would people have had a better chance of survival if it had been in the daytime? Would there have been more warning? Would people have noticed the lahar and raised the alarm? So maybe time of day had an effect? Level of development. Do you think, let's take, what should we take? Tsunamis. Do you think more developed countries are more prepared to deal with tsunamis, or do you think tsunamis just affect everybody equally? So the notes column is very personalised to you. It's just to get you thinking about how these hazards stack up really, which are worst, which affect most people, which ones are international, which ones are local. Doesn't have to be full of information, and if you're not feeling confident, just do it in pencil and we can talk about this in class at a future date. So fill in the third column, then rank them from worst to least bad. I would really like you to have a go at this task, and it might be a thing where you can actually do this with a couple of other geography students, a bit of discussion, negotiation. Which do you think is worst? Which do you think is like the least bad? I don't care what reasoning you use. And actually I would be quite interested if people had completely different reasonings. This is, if coronavirus hadn't have happened, we would have done this in class, and it leads to some really interesting decisions and thought processes, and we will do it in reality in the future, but maybe you might want to have a go. Then, I don't know how much time you're going to have over the summer, but if you get a bit bored, this is a more than 2-hour documentary about volcanoes. It's quite good. I'm not going to lie, it's not thrilling throughout, but it's pretty good. And it would really begin to consolidate your learning about volcanoes up until this point. So that would keep you out of trouble for a little while, wouldn't it? Okay, well done. So you have finished the hazards section, ladies and gents. And we're pretty near the end, basically. Sorry. But we're pretty near the end of what we want to do by the summer, so you're nearly there. Hang on in there, folks.